Okay, so sometimes when you start doing problems that are really difficult, you forget and you look at something like this and you think, well, what is u supposed to be? I'm not sure which one that is. You know how to do this. This is just the add 1 to the power and, divide in the coefficient. So what would be the antiderivative of this number 1? Just going back to November. Yep, plus c. Don't forget plus c. And so I call this the basic rule because it's just your basic way of integration. And back in December, we had a test over this, and you guys did really good at that. And some of them, though, were a little bit more difficult. So like looking at this problem 2, you can do this with the u substitution, all right? But you don't have to, all right? And I'm really going to work this first one so that I can lead into the second one. So on this first one, what could you do to avoid u substitution? Yeah, what do you mean by that? Yeah, I need to multiply it by itself. Okay, and x plus 5 squared is not x squared plus 25. I will physically cry on your paper if you write that. Okay, some of you might have even been thinking that, and I'll spare it. You don't have to admit it. All right, so when you multiply this by itself, x times x is x squared. The outside would be 5x. The inside would be 5x, so we'd get 10x. And then plus 25 dx. Okay, and there's a lot of these I'm not going to finish. The whole idea of this paper is really just to start them and identify which type, because once you get to this point, you can do the rest, right? Okay. All right, so I did that one so it could lead into this one, okay? This next one, u substitution, would not work in. I don't want you to write this down, but I want you to watch something. If I let u equal 2 plus e to the x, which is what you might want to do, then du is e to the x dx, right? The derivative of e to the x is e to the x. But this is nowhere to be found in the problem. So we cannot do u substitution on this one. But what we can do is expand it. And it's still not the easiest problem, but we're just gonna focus on this part. So again, I can multiply it by itself. 2 times 2 would be 4. Outside would be 2e to the x. Inside would be 2e to the x. So that would make plus 4e to the x. And then the last one would be e to the x times e to the x. What's that going to be? Which is e to the x squared. Look, if you have e to the x squared, you would just multiply the powers. 2 times x. Okay. And then you would go through and you would integrate each piece, okay? And you would have to do a little u substitution on this last piece. You'd have to let u equal 2x. But we'll get to that part. We'll do a harder one of that in a minute. But this problem without expanding it was impossible. Okay, so now let's look at this last one. Okay, this is also one that was on your test last semester. And a lot of people would miss it because they try to do quotient rule. But remember, you can't do quotient rule for integrals. All right, you got algebra skills, you got u substitution, and now you got some formulas. But you don't have product, chain, quotient rule, you don't have any of those for integrals. All right, so what's something we could do? Use algebra to rewrite this.
Split it apart.
Yeah, rewrite it. So x cubed over x, that would be x squared. The next term would be just 4, because the x's would cancel. And then the last one would be 2, 1 over x. And this should have a dx, by the way. What's the antiderivative of 1 over x? Natural log x. Good. Okay, so we could definitely finish that problem. So, but we're not, that's the easy part. I want to spend time on the hard part, which is the beginning. Okay, so all of this, maybe not the E part, all of this was what we did in chapter 4, the beginning of chapter 4, which we did in November and December.
Could you not do x to the negative 1? Or is that...
You can't integrate 2x to the negative 1.
Okay.
Because think about it this way, if you added 1 to the power, yeah, and that would not work out. That's why I wrote it this way, and that's why we have it. So you would have, that would be at the very end, 2 natural log x. So the e and the natural log part of this is new, but the rest of this is, well, actually what we did in the beginning. And then I taught the u substitution to you right at the very end of last semester. Then we had the snow days and all that. And so this is actually what we started this semester with, and we've been doing u substitution the whole time. So I get it. When you know you're going to do u substitution, you guys are really good at figuring out what u equals. But that's not what I'm going to ask you. I'm going to ask you a different question. How do you know this is even a u substitution problem and not, or could it be solved a different way?
Because it's inside parentheses.
So it's inside parentheses squared. Could I do this though a different way? I'm going to scoot this back up just to show you. Could I have done something like this? You definitely could. It's harder on this one to do all those steps. So you could do this one without u substitution, but you guys are right. We know that it's probably a u substitution problem because I have something in the inside being squared, and more important than that, so let's go ahead and set our u, it's what happens next. Our du is going to be 2x dx. And if I divide over the half, what I want is for this to be there, this to be the other things in the problem. Okay, so the u part is going to go right, u is x squared plus 1. And what I'm looking for is everything else can be substituted with the du. And it can. So this becomes 1/2 u squared du. Okay? So that's how you know this is a u substitution problem. Something in parentheses being taken to a power. It could also look like a square root of something. And the derivative of that thing is also there. All right. So again, I'm not going to finish this one. I think we're good with that. All right. So the middle problem, how do you know this one's a u substitution? Okay, here's what I want you to do. I want you to write on your paper what u equals and what du equals. Go ahead and write that on your paper. And then I'm going to ask you the question again. Give you a little bit of think time. Okay, do you agree with my u du? Okay, so look at the du. This thing is the numerator. So how do I know this is a u substitution problem? Yeah, when I look at the bottom and I take the derivative, it equals the top exactly. This is how I know this has to be a u substitution. Now, even if there were a number, that would be okay, right? You can always just pull the numbers out to the side. I'm not doing that with this 2 because I want the 2. It's up here. I want it to be there. All right, so then after I do the u substitution, what would I have? 1 over u du, which is natural log of u plus c, which is natural log of x squared minus x plus 2 plus c. which should make sense because this is, I mean, think about how you take derivatives of natural log. You do basically the derivative of the inside part over itself. So it's really easy to check. All right, what about this last one? How do you know this is a U substitution? Okay, I have a radical on the bottom. What else? Yeah, I have the power. The power on E is not the normal power of just X. That's what you're going to let U equal, by the way. I get that square root of X is also in the denominator. But if you want to get to why did I set the square root of X equal to U, it's because it's the power on E. This problem was on the last test, by the way. And on the quiz before that. This exact problem. Okay. Move that 2 over. And this next step is where people got this one wrong. So we have the 2, we write it out in front, and then people said, oh, square root of X, X is U, 1 over U. They're forgetting about the E, and they're also not looking at the du. Look, that takes care of that square root of X. This square root of X on the bottom isn't U anymore. It's part of the du. And so what should I have right here? E to the U du. And the nice thing about e to the u is the integral is e to the u. And so I end up having 2e to the square root of x power plus c. Okay, so just to kind of recap this, we do use substitution when we have things in parentheses with powers, when the thing on the numerator is the derivative of what's on the denominator, and when we have e to strange powers. These aren't the only times we do use substitution, but these are definitely the most common ones. All right, TOCO. What does TOCO mean? Do you remember what it stands for?
The other kind of.
The other kind of. So we have these U substitutions where everything lines up nice and neat. TOCO, it doesn't. So let's just go ahead and just start the problem. What do you think U is supposed to equal in this one? 1 minus x. Then du would be negative 1 dx. Divide over that negative 1. Okay, so I'm going to go ahead and write this negative because I'm really afraid I'm going to forget it. I did in my second period class, so I'm going to go ahead and write it now. And I have square root of u du. And the problem is there's nothing, x squared isn't anywhere. Like it should be right over here, but it's not. So what do I need to do? Find x. Okay, so we use the top equation. If u equals 1 minus x, what does x equal? 1 minus u. So that's what I have right here. 1 minus u squared. Okay, I made my other two classes suffer through all the nitty-gritty of this, but I will say that y'all's class does this better than my other two classes, so I'm not going to make you do that. But also because I want to make sure that I give you time to work on the reviewing class. Okay? But let's talk just briefly. What generally do I need to do with this before I integrate? What do I need to do with this square root of u? U to the 1/2. What do I need to do with this 1 minus u squared? Expand it, and then I need to distribute. And then you get a lot of messy fractions, and you use the basic power rule and all that, okay? A lot of times, though, this is as far as you're going to need to go, okay? Most of the time. Right? Never on an AP test are you going to have to do this problem in its entirety. It would possibly be a multiple choice, but it probably wouldn't be x squared. It'd probably just be x. And so I'm going to go ahead and move over to the back because I want to spend some good time on the trig part. So on the back part of this paper, the next thing we're going to be looking at is trig. We haven't talked about trig yet. So let's write down what we know. Let's do derivatives first. Okay, so if you know it, tell me. And I want as many of you, if you know it, tell me. I want y'all to participate with this. This is a good review. So what's the derivative of sine? Cosine. What's the derivative of cosine? Good, negative sine. What's the derivative of tangent? Secant squared x. What's the derivative of cotangent? So if the derivative of tangent is secant squared, the derivative of cotangent would be negative cosecant squared. You just negatives, you just put the co, and the co goes everywhere. Okay, so what's the derivative of secant? It's not a co, so it's not negative. It's just secant x, tangent x. You could write it as tangent x, secant x. Okay? So then what's the derivative of cosecant? Negative cosecant x, cotangent x. Alright? Now, you have flashcards that have all the trig derivatives and integrals on them. Okay, so those were all the trig derivatives, which I think if given some time, you'd probably be able to come up with it. And so, what I want to talk about now is the trig integrals, which we have not spent as much time on. Okay, sine and cosine, they kind of go back and forth. But tangent isn't the derivative of anything really obvious. So when I asked you to integrate tangent, the very first time we did this, we rewrote it, and then what did we do next? Yeah, we let u equal cosine, and then we did it from there. We discovered a formula. And then I told you, you need to memorize these. Alright? It wasn't on that test, because that was the very last thing we learned before the test. Now you've had time, and these are on your flashcards. Any of you already have it memorized or remember what the integral of tan x is? I'll tell you, it has a natural log in it. Close. It's natural log of cosine x. And since there's a co, this time we're not integrating co, so it's negative. It has a co in it, so it's negative. Okay? You have it, one of your flashcards is this. If you have not started studying those, you need to. This is why I gave it to you last Friday, so you'd have over a week before our test over these. Okay? If you didn't know this, you would have to do it this way, which is okay, but I will tell you, secant's a lot harder. All right, before we do secant, if the integral of tan x is negative natural log cosine x plus c, what is the integral of cotangent x? Natural log sine x plus c. Okay, so they're related that way. If you know one, you should be able to know the other. Okay, so now we do secant. Okay, we know there's a natural log in there, right? Right. Actually, I want you to get out your flashcards. I want you to find this one. And I know it's a lot. I'm asking a lot of you to memorize it. I wouldn't do it if it wasn't on the AP test.
Secant u plus tan u. Is it that? Yes.
Yeah, natural log, in this case, it's just plain x, but yeah. Okay, so, but I want you to, everybody make sure they can find this one. And hopefully your cards are in some kind of order. That would be more helpful for you while you're studying, and then when you're just quizzing yourself, mixing them up is a good idea. So the integral of secant x is natural log secant x plus tan x. Have we ever seen secant with secant and tangent before? I mean, does this relationship look familiar? Okay, let me ask this a different way. What's the derivative of secant? Secant times tangent. So the integral of secant is natural log of secant plus tangent. It's the fact that those two are so similar is good and bad. Okay, it's good because it's not like you're having to memorize a whole brand new thing. It's bad because they are pretty similar. But if you already knew the 6 trig derivatives really, really, really well, you're not going to get them mixed up. Okay, so some of you are still looking, keep looking. For everybody else, I want you to think, how do you think this is going to change if instead of secant, this is cosecant? Integral of cosecant.
Oh, it's just gonna, it's gonna be negative. It's gonna be
I think it's probably going to be negative, and these are going to have cos in front of them. Okay, find the card and let's confirm that. Find the card that says cosecant. And let's just make sure. Does it work out that way? Okay, so that's good. So it's not like you're having to memorize all these things separate from everything else. I don't suggest Monday night at midnight you say, oh, I got to memorize all these. It's too late. You're not going to memorize them in one night. You need to start, first of all, with the 6 trig derivatives, if you don't know those. Then you need to move on to these, and then you need to move on to inverse trig. Okay, I know it's a lot. This is why you have flashcards, and this is why I keep saying it. You've got to study. There's no way out of this. Okay. Okay, so let's talk about inverse trig. These are also on your flashcards, but I want to encourage you to see if you remember this one. We just had this on our quiz yesterday. And so, first of all, I know it's inverse trig because there's a square root and a difference of squares. It's a squared minus u squared. Okay? So which one of the 3, arcsine, arctangent, or arcsecant? Arcsine. Okay, arctangent would be if the x term was first, and probably if there was an x right here. All right, so this is going to be arcsine. The 5, by the way, I'm going to move out. Okay, so let's go ahead and mark our a. That's 4. Our u is 3x, right? Because 9x squared is u squared, so just u is 3x. So du then is going to be 3 dx. And if I divide over the 3, I need to put a 1/3 out, or I'll just put 5 over 3. Okay, some of you missed some points yesterday, and you would have caught them if you had been more thorough, and that is we are going to substitute all this stuff in. So I'm going to have my du, I'm going to have my square root, a squared minus u squared. Oh, that was weird. Did y'all see that? Kind of got darker blue. Darker and blue, whatever. Okay, and then from here, I'm still not even going to go over here yet. I'm just going to write the formula. Arcsine u over a plus c. This is not something I'm requiring you to do. There's 2 reasons. You will memorize the formulas quicker if you write them every time you use them. That's one way your brain will remember them. Okay, the second thing is, it's an easy way to make sure you did it right. It has to match up. You write it, then at the very end you go back and you say, okay, u is 3x and a is 4. Okay, some of you on the quiz yesterday, you just looked at this and you tried to go straight here. And some of you did it correctly, but most people made mistakes. All right, and you don't want to make a mistake just because you're lazy. Okay, don't be lazy, especially on a quiz or a test. And I think after we practice this for a while, maybe you can go straight here to here. But right now, this is still new. Just write it out. How many of you think you have the arcsine formula memorized? Okay. That would be something I would start with immediately. Memorize the arcsine one. Then you'll notice the patterns. They all have u over a. The arctan and the arcsecant have a 1 over a in front. Okay? And then which one has the absolute value? The secant one. Okay? Remember, you got inverse, trig, derivatives, and integrals. So very similar, though. Okay, the last two things I want to talk about are problems that could be in any of these. You can use it with natural log, with E, with trig, with inverse trig, and that is just when you're given something and if U substitution does not immediately work, you got to think. It might be TOCO, or maybe there's something algebraic that I missed, okay? Then you want to look for this. Don't assume it's a really hard TOCO problem. So what I mean by this is, yeah, okay, we see separate the numerator. Don't write this down. But if you were doing just a U substitution, you may say, oh, let U be the denominator. Then du is negative sine x dx. But, you know, this is 1 plus sine x. That doesn't make sense. Okay, so you get stuck here. Okay? It doesn't make sense for me to do 1 minus du at the top. All right, so I got to think, okay, there must be something algebraic I can do. And that is to separate the numerator. So this is, I'm going to separate it out into 1 over cosine x dx, separating the numerator right there. And then sine x over cosine x dx. What's another way to write 1 over cosine? Secant x. Good thing we just looked that one up. And this would be tan x dx. So again, you'd look it up on your flashcards. So right now, later on, you would pull it from your memory flashcards. You've looked at your flashcards so many times, you can like see it in your mind, and you would remember what it is. Okay? All right, the next one. We saw, you had one like this on the quiz yesterday, and y'all did really good at it, although we had reviewed, and I made a really big deal out of this the last 2 days before. If you're looking at this and you're like, oh, the bottom looks like arctan, but the top, there's 2 things in the top. Well, then just separate them. X over x squared plus 25 dx, and then minus 1 over x squared plus 25 dx. And now I have 2 integrals. Yeah. Which one of these is the arctan? Yeah, because there's a number. And there's a number up here. That's going to be your arc, whatever, if you look at the denominator to figure out. What are you going to do then for the first one? Yeah, just regular old U substitution. In this case, U is going to equal x squared plus 25. Du is going to be 2x dx. Okay, and then you continue the problem. Are we gaining confidence or are we losing confidence? It's hard to read, y'all. I don't know. Or y'all just like ready for the weekend? Yeah, me too. Okay. How do you know you want to do long division?
If there's a higher power on the top.
If the higher power is on the top. If the degree of the numerator is bigger than the degree of the denominator. Do y'all want to see me do a long division? Okay, I'll do it. The rest of you can just work on your review if you want. All right. Okay, so this is how you set it up. Notice I put in 0x so that everything will line up nice and neat. Okay, x goes into 2x squared. 2x times. And if you're not sure how to get 2x, just think, what times x will give me 2x squared? Okay, so 2x then times 1 gives me 2x. You multiply to basically distribute to everything right there. Then you subtract. This is the step most people forget. They know the first term is going to cancel, but they forget to subtract and change the signs. Okay, that makes that negative 2x, and then I bring down plus 1. I'm going to switch colors here just to emphasize. This is round 3. X goes into negative 2x. Negative 2 times, because negative 2 times x is negative 2x. And negative 2 times 1 is negative 2. So what's the remainder? Okay, so if you don't subtract here, I'm kind of purposely trying to trick you a little bit, sorry. You gotta subtract, some of you are way too smart for me, for my tricks, it's 3. So you gotta subtract. If you thought, oh, it's -2, or if you forgot to change the sign, you might think it's -1, and then you get 3 over x plus 1. Okay, and remember, this is what you're integrating. So then you just go through and you integrate each piece. And if you need to do a u substitution on the pieces, you would. Typically, the last piece is either going to be inverse trig or u substitution, like a natural log one. Okay.